So we have seen the four potentials and how they decide things regarding equilibrium and spontaneity. So now we will look into pure substances and how they transform. First of all, what is a pure substance? So the question is, what is a pure substance? So as the name suggests, pure substance means something that has uniform chemical composition. Okay. So a pure substance has uniform chemical composition. So you can say that a pure substance is homogeneous throughout, as it is composed of a single species. Usually it's composed of a single species and it is homogeneous throughout. So one of the main things that has to be taken note of is a pure substance exhibit physical and chemical properties. The thing of unique, it does not mean that it's the only thing that exhibits that property. It just means that it has well-defined physical and chemical properties. Like in case of physical properties like boiling point or melting point, or say it's Young's modulus, they're all well-defined. Well-defined in the sense it does not change from point A to point B. Even if I take a sample from point A and I take a sample from point B, they would be identical, provided the surroundings are identical. Okay, so they exhibit well-defined characteristics, provided the surroundings are identical. Similarly, they will have well-defined chemical properties. So these are called as pure substances, or these are things that are going to be classified into pure substances. One of the core things of pure substances are that pure substances can exist in all the three phases. Okay. In case of thermodynamics, we are only worried about three phases, that is solid, liquid, and gas. Downly for mechanical engineering, we'll be worried about only the liquid and gas phase down into the gas phase, because the gas phase is used to drive steam turbines or engines, or say or other power generating units. Okay. So the transition between gas and liquid is also important. And in that sense, these are very important. Okay, we are much interested in the liquid and gas phase when it comes to thermodynamics. So they exist in solid, liquid, and gas phase, and the system under analysis. The system under analysis will have a working fluid. That working fluid, if it is assumed to be a pure substance, can coexist in the combination of these phases. So even if they coexist in the combination of these phases, they are considered as pure substance. So they can exist as solid and liquid. They can exist as liquid and vapor or gas. They can exist as solid or solid and vapor. They can even exist in a coexist in an equilibrium of these three phases. That is solid plus liquid plus gas. So even if in a system they exist in these phases even if they coexist in these three phases, or even if they exist in a pure phase or pure form, or in a single phase, they can be considered as a pure substance. So I think this would summarize a pure substance. A pure substance is chemically identical throughout. It has unique properties, so they can coexist, or they exhibit the solid, liquid, and gaseous phase, and they can even if in a system all these different phases, they are considered as pure substance. So for examples of pure substances would be something like water, or hydrogen, oxygen, carbon dioxide, mercury, iron. So all these are considered to be pure substances. One key thing to notice that air is also considered as a pure substance. The air is also considered as a pure substance provided in the system it does not undergo phase change. So air is considered as a pure substance as long as there is no phase change. If there is phase change, air is not considered as a pure substance. We know that air is composed of nitrogen, oxygen, carbon dioxide, carbon monoxide, water vapor, etc. So air is composed of all these things. So even dust particles. And air is considered to be a homogeneous mixture of these things. So it does not matter where we take air from. Wherever we take air from, it does not matter what city it is, or which place it is. It exhibits almost. We assume that it exhibits almost similar properties. Okay, so this it can be considered to be a pure substance only when it is in a gaseous phase. Once it begins to change its phase, the different components of air fall out at different temperatures. Hence, its homogeneity would be no longer valid. Hence, air would no longer be considered as a pure substance. Water is a very important pure substance and will be extensively used in this lecture. So water is abundantly available and non-toxic, and it has quite high heat capacity. So it can be used to transport energy. Okay, it can be used to transport energy, which can be further used to convert energy from one form to another. So water is extensively used. Water is one of the key driving forces of nature. It exhibits a property, or water is designed, one can say that water is intelligently designed to have life-sustaining properties. Like water when it is cooled, we all know that water when it is cooled, like it has its highest uh, density or lowest specific volume at 4 degrees Celsius in standard temperature and pressure. No, standard pressure. In 1 atmosphere, it has its highest density at 4 degrees Celsius. So what this means is just that in case of rivers and so on, even if it is cold, like if the temperature falls below freezing, the surface water may freeze over or become ice, may get frozen over. As water at the lower region, as water has its highest density at 4 degrees Celsius, the lowest layer will still be at 4 degrees Celsius, and this water is never exposed to ice. This will never become ice. This will be like whatever the temperature is. Here it will be like 3 degrees Celsius, here 2, 1. So as we have this kind of a strata, life forms can survive in this layer. So it is very intelligently designed. So as to have this kind of density gradient. This is not for like 4 degrees Celsius. This is and 1 atmosphere. This is for almost like all pressures that exhibit property like this. The temperature will be different, but it exhibits similar properties. So we look into transformation.